Previn is a pre- and post-process of Fees software based on Graphical User Interface 3D visualization package. This is used to create data files for Fees solver and post-process the results generated by the solver. Previn is driven by commands to create and manipulate geometry, generate mesh, setting properties, loading and boundary conditions on the models. The post-processor can visualize the results in various forms like contours, animations, graphical plots, tables, etc. The GUI commands can be invoked either through the tree controls, menus, or command prompts. The models can be visualized in three-dimensional OpenGL-based display area in the Previn. Previn can model the geometry or import geometries created using standard CAD softwares in IGS or STEP format. Importing the geometry is through File Open dialog. In this tutorial, we are introducing you tools to create and manipulate geometry and generate mesh. Once the finite element model is ready, various options to set properties, boundary conditions, carrying out analysis, visualizing the results, etc. are explained. The menu items executed using user actions corresponds to a command execution in Previn, which is also invoked through the tree controls and command lines through Previn windows or script files. Next, we are going to explain menu options available for working with geometries. Geometry creation includes creating points, curves, surfaces, volume. It also includes options to define arbitrary planes, local coordinate systems, and Boolean operations on geometry. For geometric primitives, Previn has commands to create, copy, move, and modify. And miscellaneous commands like erase, delete, find, show, label, and setting colors. Boolean operations includes intersect, cut, and fuse options. Next, we are going to see the commands to generate and manipulate finite element mesh from the underlying geometric model. Previn can generate 1D, 2D, and 3D meshes. 1D elements include bar, rod, and truss elements. 2D elements include quad shell, triashell, axisymmetric, plane strain, plane stress, axisymmetric viscoelastic, plane strain viscoelastic elements. 3D elements include solid, hexa, and tetra elements. Element types for 1D, 2D, and 3D models for heat transfer analysis are also available in Fees software. Meshes can also be manipulated using edges and faces through sweep and extrude. Now there are special elements like glue, mass, tying, rigid links, spring, gap, and fasteners. There are commands to create finite element nodes by specifying the coordinates or by specifying on a plane. Nodes can also be modified, merged, or renumbered. Elements can also be created by nodes, surface extrude, and node sweep. Elements and nodes can be grouped under different user-defined names. Elements can also be classified under different substructures. Next, we are explaining commands to define different types of loads and boundary conditions. Structural analysis boundary condition is based on setting displacement values at specified degrees of freedom. There are commands to add, edit, delete, erase, find, and show displacement boundary conditions. Heat transfer boundary conditions include specifying nodal temperature, heat flux, heat generation, convection, and radiative emission. Commands to add, edit, delete, show, erase, and find these boundary conditions are also available. There are commands to define and manipulate multi-point constraints on Fees models. Loads include point load, pressure load, edge load, body force, acceleration, centrifugal load, and temperature. Commands to manipulate these loads are also available. Next, we are explaining commands to manipulate material and physical properties of a Fees model. The material properties include isotropic, orthotropic, anisotropic, viscoelastic, heat transfer properties, and layered properties for composite material models. Physical properties includes thickness, beam properties, and material angle. There are options to define functions in table form and expressions. Gauss points can also be defined for a particular element. There are commands to define non-structural mass and optical data on FEIS models. FEIS support various analysis capabilities which includes static, free vibration, buckling, transient response, frequency response, random response, shock response, XFEM-based fracture analysis, viscoelastic, nonlinear static, heat transfer steady state, and transient analysis. FEIS solver can be invoked from the Previn through execute FEIS command. Results can be visualized in Previn. There are several commands to visualize the results in various forms. Previn and FEIS solver communicates through data file and output file in ASCII format. There is a binary output file which is used by post processor to read the results from solver.